We're getting into real hard topics now. I have to think. I really hate thinking. My channel. Okay, we are live. Alright. Let's pull this up. Okay, so we're on error problem 4. 54. Alright. Let's see how this can blow my brain. Okay. So we have a struct that is just a U64. Takes a value. How do you access this? How do you even access? There's this. That's just a tuple. But you call it a struct. Okay. So self adds value as U64. Oh, interesting. So this is your cast. Huh. Interesting. So what's wrong? This function shouldn't always return an okay. Well, I don't think it is. I think we've already accomplished that. I think we're on, yeah, okay. 35, okay. This exercise is an altered version of error 4 exercise. It uses some concepts that we don't get to until later in the course, like box and the from trait. It's not important to understand them in detail right now, but you can read ahead if you like. For now, think of box dynamic type as an I want anything that does something type. Alright. In short, this particular use case for boxes is for when you want to own a value and you care only that it is a type which implements a particular trait. To do so, the box is declared as a type dynamic trait, where trait is the trait the compiler looks for on any values in that context. For this exercise, that context is the potential error which can be returned in a result. Freaking thinking. This is required so that creation error can implement error. Okay, so we have display, implement display for, okay, so this is what I'm assuming. This is a function for this. Okay. Alright. Okay. That makes sense. Implement error for creation. Okay. So it just does nothing. Okay. So positive non-zero integer as 24, and that returns a non-okay. Sounds fine. Alright, to do. Add the correct return type, return dynamic box. What can we use? Add the correct return type. Where? What can we use to describe both errors? Is there a trait which both errors implement? I don't know. I don't know any traits. We haven't talked about traits. What do you want? So here? To do Oh. Oh, you mean here. Okay, I see. So you want box dynamic creationer? Is that a trait? What trait? What trait does it have? I don't care. So this. So before we passed. So the type is creation error. Results, is that the is it display? I actually don't know what is there a trait both errors? So okay, so this is a creation error. What do you mean both errors? Results? I don't know. Okay. I don't know what the type is. What do you got for me? I need a hint. I don't have a clue. Oh, what are you? What do you produce? This is a pretend. Okay. Well, so let's figure that one out. What does? Well, let me let's break this out and see what it should be. Test equals what coming out you for a bit. Unknown. Okay. What? Okay, so I need to specify this as an I64. Results. Results. So we'll say it's a result of something and then something else. What is that something else? I don't know. Don't know. F error. So, well, it's just error. Is it just error? Error. No. Okay, what was that? Let's try. Well, that's what I thought. Just box dynamic error. box dynamic error. All errors implement the error trait we can capture. That's what I thought. So this will return if this is wrong. Okay, so let's set this back. I'll put this back. And I'll type in error. Now, is the problem, it doesn't know what error is? Dynamic box error. Error must describe themselves through display. Error messages are typical. So, well, so you got error here, which is what this implements. Did I type this wrong? Dynamic box. Oh, okay. Nope. Oh boy. Got it though. Got it. Next question. Boosh. Number 5. Okay. Oh, number 6. Let's see. Using the catch-all error type like box dynamic error isn't recommended for a library code where callers might want to make decisions based on the error context instead of printing it out or propagating it further. Here we define a custom error type to make it possible for callers to decide what to do next when our function returns an error. Okay, so we have a custom error type that we'll be using in the positive parse, which is parse int. So that's that. What is creation? Okay. So okay. Add another error conversion function here from parse int. Okay, so you don't know what self is. Self dot creation error. Well, so I'm guessing it'll be self dot parsing error, and then parse creation %. Is not a number. Okay, so to do, change this to return an appropriate error instead of panicking when parse returns an error. Should I do this? Or was the whole point of this something? these functions, parse int. So when it actually tries to parse a number, it fails. What is self? Self is the U64. Valid digit. From creation. My brain says it should be a parse int error, but I don't. Oh, but this is this error. Why does this work? So I don't actually understand. We're getting a creation error. A new. Hold on. This is a positive non-integer value. So when you say self new, it has a creation error. And that's okay. I don't actually understand how this. We have a new. Oh, so you don't even know what's in here, do you? Okay. So, okay, I think I understand. So if parse, so this would not unknown. So I need to use the let syntax. Which should allow me to strip a lot of this garbage. Or no, I feel like I should just tackle it like this guy. So we're gonna parse the value. Can I do that? Which equals results. And if we can match. Temp X.
equals, okay, x, turn x, I'm doing this wrong. If error, no, yeah, I'm stupid. It should be this. Yeah, so it should be x dot parse. It should still be I64, and then this. Okay, so I can't do that, or unless there's an error. Parser error. I don't know. So it's not that. So parse and parse expected a parse int error. Is there a if error Rust extend add-on function for results? Rust included if the value of results is okay, it will unwrap error or return from the function and pass R to the caller. I understand this, I think, but I want different errors. I don't, what? Instead of unwrap and provide, tracking down this one. Spec looks like this. So yeah, this is what I was thinking originally. So let x equal I64, match that against s.parse, and the results would be okay, x return x, error b return So now do I have to say return? Yes, okay. I have to say return, okay. So now I want, so this takes a parse int error, so I can do from creation. Now I go do E. So that's a parse int error. You're a parse int error. And you're a parse non-zero. So this should work. But this is a part int error. Part int error. Part int error. So you want to wrap this in error? Makes no sense. What do you want? But why? You're not. Oh, I copied the wrong one. My bad. You're saying wrap this like here. Huh. Not entirely sure I get this. Let's see. Errors. Oh, okay. That's, yeah, okay. This is what I wanted. So I can use maps on more than things that are lists and stuff like that. So that's fine. Alright, what we got? Generics. Crushing. 56. Boosh. Alright, generics. Let's see what generics are. Vec_t is generic over the type t. In most cases, the compiler is able to infer t, for example, after pushing a value with a concrete type to the vector. But in this exercise, the compiler needs some help through a type annotation. You want this to be vec u8. I8. How about this? How about an I16? Cool, okay. Okay. This powerful wrapper provides the ability to store a positive integer value to do. Rewrite it with generics so that it supports any type. Adapt to do. Adapt the struct information to be generic over the wrapped value.
Okay. No clue. How do you type? So I was reading about this morning. So we have, I need struct of T. So this is just like C++. And now I need, oh, now I need to wrap this type T and wrap this in type T, if I remember correctly. Then, yeah, PT. That should be good. Cool. That worked. Easy. Generics, piece of cake. All right. Traits. Traits is a collection of methods. Data types can implement traits, and to do so, the methods taking up the traits are defined for the data type. For example, the string data type implements the from string trait. This allows the user to write string from. In this way, traits are somewhat similar to Java interfaces and C++ abstract classes. Some additional common Rust traits include clone, display, and debug, which allows format display. Oh, that's cool. Which allows format displays via the, I don't know what that is. Because traits indicate shared behavior between data types, they are useful when writing generics. Alright, good to know. Traits. The trait append bar only has one function, which appends bar to any implementing this trait. For the type. So you have trait append bar implement. So it implements for string. So, okay. Okay. I need to make it a function. Foobar. Okay. Okay, so forced. Okay, so it's attaching to string the ability of foobar. So dot push okay. Self dot push stir foobar. Not what I want. I just did that. String. What? Let's keep going. Keep going the way I know, and then we'll just go from there. No. Mute.
So that too. There's probably a cleaner way of doing this. Something. Oh. See, this is what I'm like. I don't know. Okay, so not. All right. Next. All right. To do, implement the trait append bar for a vector of strings. Append bar should push the string bar into the vector. Implement the trait append bar for a vector. Okay. So I have to implement append bar for vector type string. That's what we're gonna go roll with. Vector. No, it's definitely vector. Nice. Vector. Do I have to include? Oh. Vec. Okay. So. Am I? String from. Oh, so it's only putting one. So dot push. String bar. Okay, so another one I'm assuming I did wrong. So how did I do wrong? Oh, no, I did it right. Sick. Oh, okay. Trait number 3. To do. Add a default implementation for license info so that implementators like the two strokes below can share the default behavior without repeating functions. The default license information should be the store default list. Okay, so okay. Duh. Do I add it here? The default information from license was 2 strokes below can share the default behavior without don't edit these lines.
Okay. Can I edit in here? I can't say. So what's interesting is okay. So let's do a string from okay, so I should be able to do self dot version number. Can I so the question is, let's go traits. If I could add a generic trait. So I could add a type T generic to this trait now, but I can't. Can I do T dot int? Let's see. I want a trait. I don't see any traits. Oh, public trait. So it's not. I don't have a trait on types. So let's try T dot version number. Displayable. So what was it in the README? Display, trade up display. That's not what I want. So it's not that. I don't know. I need a little help here. Give me a little sugar. Trades can have default data times to the trade. Can use the default version function not to implement the function. I understand that, but how do I get the values out of it? I need to format. What's the intro? It's like heck. I put this in my Notion page if I remember correctly. Format. So this is what I want to do. I want to do format. And then this. Then this. This is what I want to do. I think. But default implementations, okay. If you say so. Default implementation. Sometimes default implementations for traits. We specify a summary, method summary, trait instead of only define the method signature as we did. Okay. To use a default implementation summarized in URL, we specify an empty imply. Even though we no longer define the summary message directly, we provide the default implementation. Summarize. That makes sense, but how? Well, I can. What's the test? Oh, I'm not supposed to add. Oh yeah, easy. I'm not formatting it. Is that what you want? Two-string? It's fair enough. Alright, I think we've accomplished beautiful things. So I think we're